Hi everyone, welcome to the session on Agile methodology. So in this session we are going to see the topic as design and development practices in Agile project. In Agile, design and development are not done as separate long phases like in the traditional waterfall model. Instead, design and development happen iteratively and collaboratively. Agile teams focus on building working software step by step, improving it continuously based on feedback. In this section, we will explore engineering practices used in the Agile such as simple design, continuous integration, test-driven development, refactoring, and pair programming. These practices ensure that the software is developed with a high quality, less work, and faster delivery. Now we'll see introduction to Agile design and development practices. Agile design and development prioritized adaptability and continuous delivery of valuable software. In Agile, the main focus is not just on building the software but on delivering value to the customer continuously. Unlike traditional methods where design is completed fully before the development starts, Agile design grows step by step. This makes it easy to adapt changes during the project and ensure that what we build always meets the customer expectations. They draw heavily from lean production and the theory of constraint to maximize the value flow. Agile design principles are inspired by lean manufacturing concepts like reducing waste, improving flow, and delivering the faster. It also uses the ideas from the theory of constraint, which means identifying the bottlenecks in the development process and removing them to speed up delivery. The goal here is to keep the value flowing smoothly to the customer. These practices embrace uncertainty and promote continuous improvement over the rigid planning. Agile accepts that change is natural in software development. Requirements may evolve, customers' needs may shift, and new ideas may emerge. Instead of resisting change with the strict plans, Agile welcomes the feedback and continuously improves the design. This helps in building better products over time. Agile contrasts sharply with the traditional phase gated approaches that enforce heavy upfront design. In traditional waterfall project, there is a long design phase at the beginning and everything must be planned in detail before coding starts. But this approach is risky because if requirements change later, huge rework is needed. Agile avoids this by using the simple and incremental design, reducing the effort and avoiding the waste. The goal is to enable the frequent delivery while maintaining quality and minimizing the waste. Agile design practices aim to build and deliver working software frequently every week or every sprint. At the same time, Agile maintains quality using good engineering practices. By avoiding unnecessary features and big upfront planning, Agile minimizes waste and focuses only on what really matters. So, overall, in short, Agile design is simple, flexible, and customer focused. It avoids heavy documentation and encourages regular delivery with a high quality. And next one, iterative and incremental development. Agile delivers working software frequently from weeks to couple of months, ensuring the rapid feedback. In Agile, development happens in short cycles called iteration or sprints. Instead of waiting till the end of the project to show result, Agile teams deliver small working features regularly every 2 to 4 weeks. This allows customer to review progress early and give feedback, reducing the chance of building the wrong product. This approach reduces the lead time and keeps inventory low, aligning with the lean principles. Lead time is the total time taken from starting a task to delivering it. Since Agile works in the short cycles and delivers the features quickly, the lead time is reduced. Also, work in progress inventory stays low, which means there is a less unfinished work lying around. This matches lean principles of speed and efficiency. Development happens in a small batches, which supports smoother flow and better quality. Agile avoids building a large modules at once. Instead, work is broken into smaller, manageable parts. This makes development easier to manage. It improves the testing and ensures that issues are found early. As a result, the overall quality improves. A next point is the larger batches increase work in progress, causing delays, higher inventory, and quality risk. When too much of work is taken up at once, it causes delays and increases the chance of mistakes. More incomplete tasks are mean more confusion, more waiting time, and more defects. That's why Agile avoids large batch development. Small batch sizes reduce uncertainty and allow quicker adaptation to change. By working in small batches, it becomes easier to change directions whenever needed. If customers' requirements change, it is easy to adapt because only a small part of the system is affected. This keeps the project flexible and responsive. So, iterative and incremental development is a key agile practice that improve flexibility, reduce risk, and increase customer satisfaction. And next one, handling the requirements and design. Agile welcomes the changing requirement even late in development for competitive advantage. Unlike the traditional methods where changes are seen as a problem, Agile accepts changes even in the later stage of development. This flexibility helps organizations respond quickly to customer needs and market changes, giving them competitive advantage. The best design and architecture emerge from self-organizing teams rather than upfront plans. Agile believes that good designs evolve during development. Instead of spending months creating a perfect design upfront, Agile encourages developers, testers, and designers to collaborate and improve the architecture step by step based on real project needs. Just enough design initially, that is JD, balance shallow modeling with the rapid progress. This principle means doing only the minimum necessary designs at the beginning, just enough to start development. More design improvements can be added as the product evolves. This avoids over planning and keeps development moving quickly. Prioritizing requirements by minimum, desired, and optional levels enables the scope buffering. In Agile, requirements are categorized as minimum, that is a must-have features, desired, important but not critical, and optional, nice-to-have features. This helps teams focus on delivering the most important features first and manage changes easily without delaying the project. This adaptability mitigates the risk from interface changes and minimize the regression effort. Since Agile develops the software in small increments, any impact of change is easier to manage. If user interface changes or integration issues arise, they can be handled early. This avoids large rework and reduces regression bugs. Agile handles requirements and design flexibly, reducing planning waste and responding to change efficiently while still maintaining the product quality. Mm, Next slide, we'll see the collaboration and communication. Daily collaboration between business stakeholders and developers is critical for success. In Agile, business people and development teams do not work separately. They interact daily to share ideas, clarify requirements, and review progress. This regular communications ensure that the product being built actually meets business needs. On-site client involvement reduces misunderstanding and early detection of design issues. Broader explanation of the on-site client involvement is when clients or product owners work closely with a team, they can immediately clarify doubts and correct the misunderstandings. Their presence helps identify the design or requirements mistakes early, saving time and effort. Face to face conversation is the most efficient communication, minimizing the documentation waste. Instead of the long emails or lengthy documentation, Agile prefers a direct communication, especially face to face discussion. It is faster, clearer, and avoids a confusion. This helps eliminate the unnecessary documentation and speed of the development. Direct communication accelerates the decision making and reduces the delays from rework. When people communicate directly, decisions are made quickly. There is less waiting time for approvals and fewer chance of miscommunication. This prevents rework and keeps the project moving without delays. This approach fosters trust, transparency, and a quick response to changing the needs. Strong communication builds the trust between teams and clients. Everyone knows what is happening in the project, which creates transparency. It also helps the team respond quickly when the changes are needed. So, effective communication and collaboration are at the heart of Agile. They reduce conflict, prevent delays, and keep development aligned with the customer expectation. And next one, the quality assurance and test. Continuous focus on technical excellence enhances the agility by reducing the costly rework. In Agile, quality is not checked at the end. Instead, it is maintained throughout the development. By writing the clean code and following the best engineering practices from the beginning, Agile teams avoids the rework later, which saves the time and effort. Unit testing and peer reviews catch defects early, improving the code quality significantly. Agile encourages the writing unit tests to verify each small piece of code. Peer reviews allow the team members to check each other's code. Both practices help find and fix bugs early before they grow into bigger problems. In extreme program, developers perform code testing during iteration, customers handles acceptance test. Extreme programming, developers don't wait for the separate testing phase. They test their code continuously during each iteration. After that, customer perform acceptance testing to check if the software meets their requirements. Automated integration testing elevates quality and prevents the integration bottlenecks. As the software grows, different modules need to work together. Automated integration testing ensures that new code smoothly integrates with the existing system. This prevents integration failures and speeds up delivery. Continuous refactoring keeps code clear, flexible, and adaptable to future changes. Refactoring means improving the code structure without changing its behavior. Agile teams frequently refactor code to keep it simple and easy to update. This helps future development and prevents the code from becoming complex. So, Agile maintains quality through early testing, automation, and continuous improvement. This reduces risk and ensures the reliable software delivery. And then next one is the feature driven development practices. FDD uses a 5-stage model: shape modeling, feature list, planning, design, and build. Feature driven development is an agile method focused on delivering the features step by step. It follows a structured 5-stage model. Shape modeling: understand the overall system structure, that is a shape modeling. Feature list: break the system into small user required features. And next one is the planning: decide which feature will be built and when. And next one is design: create the design for the feature. Build: develop and test the feature. This structured approach makes the feature driven development easy to manage in large projects. It leverages the UML archetypes and domain neutral components for the resilient architecture. FTT makes use of modeling tools like UML, Unified Modeling Language, to clearly define the system structure and behavior. It also uses the software design patterns like archetypes and reusable components to ensure the architecture is strong, scalable, and easy to maintain. Features are small, client valued units typically deliverable within 2 weeks. In FTD, the main focus is on delivering the features that give value to the customer. Each feature is small, meaningful, and can be completed quickly. Usually within 2 weeks, this allows continuous delivery and fast feedback. Strict class or file ownership maintains the code quality and accountability. In FTD, each class or module in the code is owned by a specific developer. This ensures high responsibility and better code quality, as each developer takes care of maintaining and updating their part of the code efficiently. Featured teams led by chief programmers build small batches called chief programmer work package. Development in FDD is done by small featured teams. Each team works under the chief programmer who guides the team and integrates the features. The work assigned to each team is called work package, making the development organized and efficient. So, FDT is a disciplined agile method focused on planning, delivering the features with a strong design and a high quality coding practice. So, next one is the extreme programming and that code. Extreme program relies on customer written user stories refined continuously for development. Extreme programming begins with the user stories written by the customer or product owner. These stories describe the real user's needs in the simple language. Throughout the development, these stories are refined with more details so developers always build exactly what the customer expects. Pair programming improves code quality by doubling the review during coding. In extreme programming, two developers sit together at one system and write code as a pair. One writes the code driver while other reviews it instantly. Navigator. This real-time review reduces bugs, improves the logic, and encourages the knowledge sharing across the team. Continuous integration merges the code frequently, detecting the conflicts and faults early. Instead of integrating the code at the end, extreme program teams integrate the code multiple times daily. This is called continuous integration. It helps find and solve integration problems early. It avoids the merge conflicts and keeps the software working at all times. Test-driven development ensures that test precede code creation for quality. In test-driven development, developers first write a test case before writing the actual code. This forces them to think about the expected behavior of the code. Only after the test fails do they write the code to make it fast. This ensures high code quality and reduces the bug. Collective code ownership allows any developer to modify code, promoting the flexibility. In XP, no part of the code belongs to one developer. Everyone owns the code collectively. Any team members can change or improve any part of the system. This prevents dependency on individuals and keeps progress smooth even if someone is absent. So in overall, extreme programming focus on high quality coding practices, teamwork and continuous improvement, making it one of the strongest agile engineering practices. And next one is Scrum and rapid application development. Scrum serves as a management wrapper, organizing work in the fixed 30-day sprints for a stability. Scrum is an agile framework used to manage the projects. It divides the work into fixed time periods called sprints. Traditionally, each sprint lasts 30 days, but in modern Scrum, it is often 2 to 4 weeks. These fixed time frames brings discipline, focus and predictability to the project. The sprint backlog is logged during each sprint to protect focus and reduce disruption. Before each sprint starts, the team finalizes list of tasks called sprint backlog. Once the sprint begins, the list does not change. Locking the backlog helps the team stay focused and avoid distraction from sudden requirements changes during the sprint. Daily Scrum meetings synchronize team progress and resolve the issues quickly. The daily Scrum is a short stand-up meeting held every day, usually for 15 minutes. Team members share what they did yesterday, what they will do today, and any blockers they face. This keeps everyone synchronized and helps solve the problems early. Testing is integrated within sprints and managed by the development team. In Scrum, testing is not separate phase. It happens during the sprint itself. The development team is responsible for both the coding and testing to ensure that every sprint delivers a working software increment. Rapid application development fixes delivery dates first, adjusting the scope and budget to meet the time constraint. Rapid application development is another agile model that prioritizes speed. In rapid application development, the delivery deadline is fixed first and then scope and cost are adjusted to meet the deadline. This makes Rapid application development suitable for fast moving projects with the strict timelines. So in overall, Scrum ensures disciplined teamwork and predictable delivery, while rapid application development focus on fast delivery through the time boxed development. In next one is lean soft tools and automation in Agile. Automation tools like Ant enable continuous integration to speed up the build and test cycles. In Agile, automation is very important to save time, reduce the manual effort. Tools like Apache Ant, Maven, Jenkins, and GitHub Actions automate the process of compiling code, running tests, and integrating new changes. This supports continuous integrations, meaning new code is merged and tested frequently to detect the issues early. Next one is the visual controls such as the cumulative flow diagram, track workflow and highlight the bottlenecks. Visual tool help agile teams understand the current status of the project quickly. The cumulative flow diagram is one such tool that shows how tasks are moved across the different stages like to do, in progress and done. It also highlights the bottlenecks and places where work is stuck and needs attention. Parking lot diagrams provide a visualized summary of project health and buffer status. A parking lot diagrams gives a simple high-level view of all modules or features in a project. It uses colors or labels to indicate which areas are on track, delayed, or are at risk. This helps managers and teams quickly understand the project health and buffer usage. These tools empower teams to self-organizing and manage the flow more effectively. With automations and visualizations tools, teams don't need constant supervision from managers. They can monitor progress on their own, solve problems faster, and control workflow independently. This supports self-organizing teams' core agile principles. Automation and visualization reduce waste, enhance the transparency, and improve the delivery predictability. Automation removes repetitive manual tasks and reducing the time waste. Visual tools keep everything transparent so everyone sees what is happening. As a result, teams can deliver software more predictably and with a fewer delays. So, overall in Agile, automation and visual tools improve the speed, quality, and team coordination while reducing the waste and avoiding the delays. Now, let's see the overall summary of the Agile design and development. Agile practices enable responsive, flexible development aligned with evolving the business needs. Agile allows teams to adapt quickly to changes during the project, whether the customer expectation change or market demand shift. Agile responds fast and keeps the development aligned with the business goals. They ensure high quality through early defect detection and continuous refactoring. Agile does not wait till the end to find defects. Testing happens from the beginning and refactoring keeps code clean and maintainable. This leads to better quality software with fewer bugs. Collaborative communication minimizes the waste and accelerates the decision making. Agile promotes strong communication through daily stand-up, team discussion, and customer involvement. This avoids misunderstanding, eliminates unnecessary work, and speeds up decision making. Small batch delivery reduces risk, lower inventory, and shortens the lead times. Instead of delivering the big project all at once, Agile delivers in small increments. This reduces risk because issues can be found early. It also reduces work in progress, shortens the delivery time, and improves the efficiency. Collectively, these practices drive efficient, predictable delivery of valuable software. All these agile practices together lead to faster, smarter, and more reliable software development. Teams deliver value consistently while staying flexible and maintaining high product quality. So, agile design and development practices improve the speed, quality, flexibility, and customer satisfaction, making them essential in modern software engineering. Thank you.